solid, liquid and gas state. So our today our discussion will be confined to the gases and liquids. So let us briefly discuss the points to be covered in the states of matter. So basically states of matter is divided into two parts. One is gas state, other one is liquid state. Now present to begin with, we start with gas state. In gas state, what are the subtopics that are to be studied? One is parameters of the gas. Parameters of the gas. What are the parameters of the gas? Every gas is defined by 4 parameters. What are the 4 parameters that are used to define a gas state? Pressure, volume, temperature and mass. What are the 4 parameters that are used to define a gas state? Pressure, volume, temperature and mass. Mass of the gas is usually expressed in terms of number of the moles, and we have to study about the units to express the various parameters of the gas for pressure, volume and temperature and mass. What are the units for the pressures? In generally, pressures will be expressed in terms of either atmospheric units or bar units. What is the SI unit for pressure? Newtons per meter square. After studying about the parameters of the gas and their units, then we will go to the gas laws. What are the gas laws? What we'll study in the gas laws? What are the gas laws? We have Boyle's law, Charles' law, Avogadro's law. Mainly Boyle's law, Charles' law and Avogadro's law. And what is the importance in the discussion of the gas laws? Every gas laws are stated to discuss the relation between two parameters, keeping the other two parameters constant. For example, the relation between the pressure and volume, when mass and temperature are kept constant, is given by the Boyle's law. What is the statement of the Boyle's law? Pressure of a given mass of gas is inversely proportional to the volume of the gas at constant temperature. When N and T are kept constant, the relation between the pressure and volume is given by Boyle's law. So the relation between volume and temperature, when pressure and mass are kept constant, it will be given by Charles' law. The relation between volume and number of the moles, when pressure and temperature are kept constant, is given by Avogadro's law. So what is the purpose of the gas laws? Gas laws discuss the relation between the two parameters when the other two parameters are kept constant. What is the equation of state? We have P1 V1 equation of state connecting the 4 parameters. P1 V1 by N1 T1 will be equal to P2 V2 by N2 T2. When N and T are constants, what will happen? When N and T are constant, P1 V1 will be equal to P2 V2, which is nothing but Boyle's law. When P and N are constants, what will happen to the relation? V1 by T1 is equal to V2 by T2. When P and N are constant, what will be the relation? V1 by T1 will be equal to V2 by T2, which is nothing but Charles' law, which is nothing but Charles' law. Apart from this, we have to go for the ideal gas equation. What is the ideal gas equation? PV is equal to nRT, PV is equal to nRT, PV is equal to nRT, and PV is equal to W by M RT, W by M RT, PV is equal to W by M RT. What will be the W? PVM by RT, PVM by RT. What will be the M value? WRT by PV, WRT by PV. And what is the expression for the density? The expression for the density, D is equal to PM by RT, D is equal to PM by RT. So, for a given gas, D is proportional to P by T. For a given gas, M and R will be kept constant, then D is proportional to P by T. For example, at what conditions neon will have highest density? Neon will have highest density. Option 1 is 0 degrees centigrade, 1 atmosphere pressure. Option 2 is 0 degrees centigrade, 2 atmospheres pressure. Option 3 is 273 degrees centigrade, 1 atmosphere pressure. Option 4 is 273 degrees centigrade and 2 atmospheres pressure. So, what is the necessary condition? Pressure must be high, temperature must be low. These conditions will be satisfied by the relation 2. So, this is the correct option. For a given gas, when pressure and temperature, when molecular weight and R value will be constant, so D is proportional to by P by T. So, at what condition neon will have the highest density? At low temperature and high pressure. Next, coming to the apart from the gas laws and ideal gas equation, and what is the R value? What is R? Universal gas constant. Or what is R? Universal gas constant. R is a function of work or energy. Because R value is given by the expression PV by NT. R value is given by the expression PV by NT. What is P? Force per area. Force by area. What is volume? Area into length. Area gets cancelled out. Force into product of force into length will correspond to either work or energy. So, R is a function of either work or energy. Next, after the ideal gas equation, there are two theories which explain the behavior of the gases, which explain the characteristic behavior of the gases. What are those laws? Graham's law of diffusion, and Dalton's law of partial pressures. Dalton's law of partial pressures. These two laws are useful to explain the behavior of the gases. What is meant by diffusion? The phenomena in which a mixture of gases, intermixing of the gases to form a homogeneous mixture is called diffusion. Why gases get mixed up to form a homogeneous mixture? Because on mixing of the gases, the entropy of the system increases. So mixing of the gases involve increase in the entropy. That is why diffusion of the gases take place in a spontaneous way, because this diffusion, intermixing of the gases proceed with increase in the entropy, that is why intermixing of the gases will proceed in a uniform way. And what are the mathematical relations we study under the Graham's law of diffusion? So R is proportional to, when P and T are constant, R is proportional to 1 by square root of D, but when pressure is also variable, R is proportional to P by root D. So for a given gas, when pressure and temperature are kept constant, R is proportional to 1 by root m. From this, laws can be, the mathematical relations can be generated. This is the basic relation proposed by Graham. Now what is the other points to be noted here? At a given temperature, set of gases having the same molecular weight, will have the same rate of diffusion. And what is the best example for the diffusion? What is the, if a gas is leaked at one corner of the room, its smell will be perceived at the other corner of the room. That is due to the phenomena diffusion. What are the other applications of the Graham's law? Using the difference in the rates of diffusion, molecular weights of unknown gas can be calculated. By using the difference in the rates of diffusion, we can separate the isotopes of an element. The phenomena is called atomolysis. Now coming to the Dalton's law of partial pressures. Coming to the Dalton's law of partial pressures. So Dalton's law of partial pressures, what is the statement of the Dalton's law of partial pressures? At a given temperature, the total pressure of the non-reacting gases mixture will be directly the total pressure of a non-reacting gases mixture is equal to the sum of the partial pressures of the component gases. And what is the partial pressure? Pressure exerted by a gas individually when the volume of the gas is same as that of the mixture of the gases. What is the important point to be noted in the Dalton's law of partial pressures? Dalton's law of partial pressures is not applicable to the gases which react with each other. Why Dalton's law of partial pressures is not applicable to the gases which react with each other? Because when the component gases react with each other, there shall be change in the number of the moles. Because total pressure of the gases mixture depend upon the number of the moles. When gases combine with each other, there will be change in the number of the moles, and Dalton's law will fail in that case. And what is the Dalton's law can be applied for the moist gas? A moist gas can be considered mixture of two. Pressure of the moist gas can be considered a mixture of dry gas and water vapor. Moist gas can be considered a mixture of dry gas and water vapor. Applying Dalton's law, what will happen? Pressure of the moist gas will be equal to pressure of the dry gas plus pressure of the water vapor. Pressure of the water vapor. This pressure due to the water vapor is called aqueous tension. Aqueous tension is indicated by F. Aqueous tension is indicated by F. The value of F, aqueous tension, will increase with increase in the temperature. At 100 degrees centigrade, it will be equal to 760 mm. So, in this, what is the other application of the Dalton's law? We can use the Dalton's law of partial pressures to calculate the relative humidity in the air. How to find the, what is the mathematical relation to find the relative humidity present in the atmosphere? Partial pressure due to the water vapor, in the mixture of air by vapor pressure of the water vapor, at the same temperature, What is the difference between the partial pressure? And vapor pressure? Partial pressure is the pressure exerted by the water in a mixture of the gases present in the air. And what is vapor pressure? Pressure exerted by the water vapor on the surface of the water when pressure exerted by the water vapor on the surface of the liquid, is called vapor pressure. Now, how to find the partial pressures? Partial pressures can be calculated in two ways. Partial pressure is equal to total pressure multiplied by mole fraction. When initial pressure and initial volumes are given, partial pressure will be equal to initial pressure multiplied by initial volume by volume of the mixture. This relation is generated by applying Boyle's law. After discussing the gas laws, we will go to the kinetic theory. In the kinetic theory, what we have to study? The postulates of the kinetic theory. What are the postulates of the kinetic theory? What are the two important postulates of the kinetic theory? Pressure exerted by the gas is due to the bombardment of gaseous molecules on the walls of the container, and at a given temperature, average kinetic energies of all the gases are same. And two assumptions of the kinetic theory are proved to be wrong at high pressure and low temperature. At high pressures and low temperature. Which assumptions are proved to be wrong at high pressures and low temperature? The molecular attractions among the gaseous molecules are negligible. That is one of the postulates of the kinetic theory that become faulty at high pressure and low temperature, because at high pressure and low temperature the gap among the molecules will be reduced. In such case, there are bound to be some molecular interactions. And what is the other assumption that is proved to be wrong? The actual volume occupied by the gaseous molecule is negligible in comparison with the total volume. That assumption also is proved to be wrong at high pressure and low temperatures. So, gases show deviation from the ideal behavior at what conditions? At high pressure and low temperature. After discussing the kinetic theory, we will go to the derivation of the kinetic gas equation. What is the kinetic gas equation? PV is equal to 1/3 mnc square. So, using this equation, we can reduce all the gas laws. After deriving this expression, we will go for the derivation of the Van der Waals equation. Why Van Waal has suggested another equation for a gas? Because Van der Waal has applied two corrections for the ideal gas equation. What are the two corrections? One is for the pressure and other one is for the volume. He has made two corrections. One is for the pressure. For 1 mole of the gas, P plus A by V square into V minus B is equal to RT. This is Van der Waals equation. We have to discuss the significance of the what are A and B, Van der Waals constants. What is A signifies? A signifies the intermolecular force of attraction. Higher the value of A, stronger will be the intermolecular force of attraction. What is B stands for? Excluded volume. Larger the value of B, larger the size of the gaseous molecule. So, he has applied two corrections, one for the pressure, one for the volume. Why he has applied correction for the volume? The space occupied by each gaseous molecule will not be available for the free movement of the other molecules. At high pressures, the impact made by the gaseous molecule on the wall of the container will be less. Therefore, the actual pressure recorded will be less than that of the in the ideal conditions. In ideal conditions, what do you mean by ideal condition? When the molecular force of attractions are absent, the pressure exerted by the gaseous molecules will definitely be more than the pressure exerted by the gas when there are intermolecular force of attractions. That is why he has applied corrections for this for the pressure as well as the volume. Now, what is the other important point? The deviations from the ideal behavior will be expressed in terms of compressibility factor. Mathematically, compressibility factor is given by Z is equal to PV by nRT. In ideal conditions, Z value will be equal to 1. When Z is less than 1, it is said to show the negative deviations. When Z is less than 1, it is said to show the negative deviation. When Z is greater than 1, it is said to show the positive deviation. What is the significance of the negative deviation and the positive deviation? When Z is less than 1, the intermolecular force of attractions are strong. When the intermolecular force of attractions are strong, the gas molecules will occupy lesser volume. In this case, gram molar volume will certainly be less than 22.4 liters. There more gases are said to be more compressible. And gram molar volume will be slightly less than 22.4 liters. When Z is greater than 1, this can happen when intermolecular force of attractions are negligible. When intermolecular force of attractions are negligible, the gap among the gaseous molecules cannot be reduced. Such gases are said to be less compressible. They occupy more volume. In such case, gram molar volume will be greater than 22.4. And what is the other important theoretical discussion that is to be carried out? So, variation of the compressibility factor with a pressure. At ideal conditions, Z value will be equal to 1. At moderate pressures, what will be the what will be the tendency? As pressure increases, compressibility factor will decrease and reaches a minimum value, thereafter it starts rising. So we have to know the reasons for that. At moderate pressures, why it is happening? At a moderate pressures, what is the Van der Waals equation? P plus A by V square, P plus A by V square, V minus B is equal to RT. At moderate pressures, V minus B will be approximately equal to V. Simplifying it, PV plus A by V, P plus A by V square, into V. V will be equal to RT, So PV is equal to RT minus A by V, dividing both sides with RT, PV by RT will be equal to 1 minus A by V RT. So at moderate pressures, which factor will dominate? This A by V RT value will dominate. As P value increases, what will happen? The Z value continues to decrease. At high pressures, what will happen? P plus A by V square, will be equal to P. At high pressures, A value can be neglected in comparison with P. Then the equation takes the form P into V minus B is equal to RT, and PV is equal to RT plus BP, PV by RT is equal to 1 plus BP by RT. So at high pressures, Z value will increase with increase in the pressure. Now at high pressures, which factor will dominate? BP by RT value will dominate. At moderate pressures, which value will dominate? A by V RT value will dominate. At some intermediate pressures, both factors nullify each other, and at that condition, gas shows ideal behavior. The temperature at which gas tends to behave ideally is known as Boyle's temperature, and Boyle's temperature is given by the expression A by RB. Now let us, after this we have to go for the liquefaction of the gases and collision parameters that we will discuss in the tomorrow's class. Now we will go to the we'll see some questions. Now what is this question should be read as the pressure exerted by mass of x ng of the gas resting on a surface of 1 square centimeter is 1 Pascal unit. Then how to find the mass value? The pressure is 1 Pascal unit. The mass is xng. Area it is covering is 1 square centimeter. Then we have to find the mass value. How to find the mass value? By definition, what is pressure? Force per unit area. But what is force? Mass into acceleration due to gravity. Mass into acceleration due to gravity. Mass into acceleration due to the gravity by area. Now what is the pressure? 1 Pascal unit. Pressure is read as 1 Pascal unit, and we had to find the mass, What is the acceleration due to gravity? 980. And what is this? A1. What is this value? A1. So we will get the mass as 0.102 grams. Substitute by making a proper acceleration due to the gravity. Acceleration due to the gravity, will get the mass as 1.02 grams. By converting into mg, it will be 10.2 mg. It will be 10.2 mg. By making proper substitution, we will get the answer as 10.02 mg. What is the formula? By definition, what is by definition of the pressure? Force per unit area. What is force? Product of mass into acceleration due to gravity, and area. Area is given as 1 square centimeter. Then what will be the mass? Pressure by acceleration due to gravity. With on simplification, we get the x value as 10.2 mg. When the pressure of gas is decreased to 1/4 and absolute temperature is increased by 4-fold, what will be the volume of the gas? What will be the volume of the gas? To answer this type of the question, we had to use P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. Since they did not mention about the mass, we can take it for granted that mass is kept constant. Since there is no mention regarding the mass, we can take it for granted mass is kept constant. Then equation is reduced to the form P1 V1 by T1 is equal to P2 V2 by T2. P2 V2 by T2. Now what happened? Let P1 is equal to P. Let P1 is equal to P, and V1 stands for V1 by T1. What is P2? Pressure is decreased to by 1/4. P2 will be equal to P by 4, P by 4, P by 4, P by 4. Now temperature is increased by 4 times. Temperature is increased by 4 times. It will be 4T2, 4T, 4T1. Temperature is 4T1. And what is the pressure? What is the pressure? 0 P by 4 means 0.25 P. 0.25 P. What is the value of V2? What is the value of V2? V2. So V2 will be equal to 16 V1. V2 will be equal to 16 V1. T1, T1 cancels out. P cancels out. So what will be the value of V2? Nothing but 16 V1. So option 1 is the answer. Next question. The 4 pipes are filled with respectively CO2, helium, hydrogen and oxygen respectively. So what is the order in which they are to be reinflated? Because at a given, when temperature and pressure are kept constant, the gas having low molecular weight will have high rate of diffusion. They get reinflated in the order of increasing molecular weight, which is gets reinflated earlier: hydrogen, followed by helium, followed by oxygen, followed by carbon dioxide. Option 2 is the answer. So here what is the point? Which gases can obey the Dalton's law? Which are non-reacting gases? In the given set, which make a non-reacting gases xenon and chlorine, because with what is A? Carbon monoxide. With carbon monoxide, we have the reaction with the chlorine, fluorine and xenon. So what is the under the given set of the option? B and D do not combine with each other. So option 3 is the answer. An ideal gas cannot be liquefied. So what is to be done for the liquefaction? The intermolecular gap must be reduced. What should be done to what should be done to for the gas to be liquefied? What should be done? The intermolecular among the gases must be reduced. Why ideal gas cannot be liquefied? To reduce the when the gap between the gaseous molecules can be reduced, when there are force of attractions, the gap among the molecules can be reduced easily, but in ideal gas there cannot be any force of attractions among the gaseous molecules. Therefore, it will be difficult to reduce the intermolecular gap. That is why ideal gases are supposed to be difficult to be liquefied, because absence of attractive forces is the major reason for the difficulty in liquefying an ideal gas. Next question. Here set of A values are given. So, in our previous discussion, we had what is the significance of A? A always signifies for the stronger intermolecular force of attraction. Higher the intermolecular force of attraction, higher will be the A value. So, the gas with high A value, for the gas with a high A value, the strong intermolecular force of attractions will be strong. Such gases can be liquefied easily. When the value of A is high, implies intermolecular force of attractions are strong. When the intermolecular force of attractions are strong, the gap among the molecules can be reduced easily. Such gases can be liquefied easily. In the given set, which has the high A value, ammonia. So, ammonia can be liquefied easily. So, option 3. Next, so in the mean free path. So, what is meant by mean free path? What is the mathematical mean free path? Will be inversely proportional to the pressure. Mean free path is inversely proportional to the pressure. As pressure increases, what will happen? Mean free path decreases. When the mean free path at 1 atmosphere pressure, mean free path is inversely proportional to the pressure. Mean free path is inversely proportional to the pressure. As the pressure increases from 1 atmosphere to 5 atmosphere, mean free path decreases from A to A by 5. Option 3. Next, 1 liter of a gas weighs 2 grams at 300 Kelvin and 1 atmosphere pressure. If the pressure is made 0.75 atmospheres, at which temperature will 1 liter of the same gas weighs 1 gram? So, simple way of this, P1 V1 by N1 T1. P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. For the same gas, since molecular weight is same, N1 can be replaced with W1 and N2. For the same gas, the relation becomes P1 V1 by W1 by M into T1, P2 V2 by W2 by M T2. So, the relation becomes P1 V1 by W1 T1 is equal to P2 V2 by W2 T2. Now, substitute. What is the initial pressure? 1 atmosphere. What is the initial pressure? 1 atmosphere. What is the initial volume? 1 liter. What is the weight? 2 grams. What is the temperature? 300 Kelvin. And what is the P2? If the pressure is made 0.75 and 1 liter And what is the W2 value? 1 gram. We have to find the T2. So solving, T2 value will be 450 Kelvin. The option is 4. So P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. For the same gas, the equation will be reduced to P1 V1 by W1 T1 is equal to P2 V2 by W2 T2. So on solving, we'll get the T2 value as 450 Kelvin. Simplifying this relation, we'll get the T2 value as 450 Kelvin. Next question. So what is the relation between the density and the molecular weight? D is equal to Pm by RT. D is equal to Pm by RT. D is equal to Pm by RT. What should be found? Molecular weight. What is the density? 2.5 grams per liter. What is the pressure? 1 atmosphere. Molecular weight not known. And what is the R value? 0.0821. What is the temperature value? 400. What will be the molecular weight? It will be 82.1. Option 1 is the answer. Simple relation. D is equal to Pm by RT. Next question. How much should be the pressure be increased in order to decrease the volume of the gas by 5% at constant temperature? This is nothing but Boyle's law. So what is the percent increase in the pressure? Percent increase in the pressure is given by the relation P2 minus P1 by P1 into 100. How to calculate the percentage increase in the pressure? Final pressure minus initial pressure by initial pressure into 100. So let us come to the applying the at constant temperature means we can apply Boyle's law. P1 V1 is equal to P2 V2. What is P1? Let P1 is equal to P. V1 is equal to V. And what will be the V2 value? V minus 95% of V. It is 5%. What should be the decrease in the pressure? So V2 will be equal to 0.95 V. What is V1? V. What is V2? 0.95 V. And what is P2? It is not known. So substitute. What is the P1? P. What is V1? V. P2 not known. And what is V2? 0.95 V. Now what is the value of P2? This V gets cancelled out. What is the value of P2? P by 0.95. Which is equal to 20 by 19P. What will be the increase in the pressure? No, percentage increase in the pressure. What is P2 value? 20 by 19P. What is P1 value? P into 100. It comes to 5.26%. Coming again, what is the question? percentage increase in the pressure. Percentage increase in the pressure. How to calculate the percentage increase in the pressure? P2 minus P1 by P1 into 100. Let P1 is equal to P, V1 is equal to V. What is the V2 value? 0.95 V, because V2 is 5% less than the initial volume. So what will be the ultimately what is the P2 value? 20 by 19 P. So increase in the pressure, P2 minus P1 by P1 into 100. So the value comes to 5.26%. Option 4 is the answer. Balloons of 4 liters capacity are to be filled with hydrogen at a pressure of 1 atmosphere and 27 degrees from an 8 liter cylinder containing hydrogen at 10 atmospheres at the same temperature. The number of the balloons that can be filled is, this is nothing but Boyle's law application. This is nothing but Boyle's law application. What is the point here? What is the point here? Initially, hydrogen gas is present in 8 liter vessel, at a pressure of 10 atmospheres, When suddenly the pressure is reduced to 1 atmosphere, volume increases. The excess volume will flow out of the cylinder. Excess volume of the hydrogen gas that is flowing from this cylinder can be used to fill the balloons. So number of the balloons that can be filled, excess volume that is flowing out of the cylinder, by volume capacity of the balloon. So balloons can be, number of the balloons that can be filled is equal to excess volume of the hydrogen gas that is coming out of the cylinder by volume capacity of the balloon. How do you calculate the excess volume? Excess volume is nothing but final volume minus initial volume. So initial volume is known, 8 liters. We have to find the final volume. What is the way? By applying Boyle's law, P1 V1 is equal to P2 V2, because the temperature is maintained constant. What is P1? 10 atmospheres. What is V1? 8. What is P2? 1. What will be the V2? 80 liters. What is the excess volume? Excess volume is equal to V2 minus V1. Excess volume is equal to V2 minus V1. 80 minus 8, 72. Now what is the number of the balloons that can be filled? Is equal to excess volume by volume capacity. What is the volume capacity of the balloon? 4. 72 by 4, 18. So when the pressure is reduced, what will happen? Volume of the gas increases. The excess volume that is flowing out of the cylinder can be used to fill the balloons. Next question. This is the problem based on the Dalton's law of partial pressure. Dalton's law of the partial pressures. What is given there? The total pressure, that is pressure of the nitrogen plus pressure of the oxygen plus pressure of the water vapor is equal to 640 mm. This is the pressure of the moist gas. How to get the pressure of the dry gas? PN2 plus PO2 will be equal to 640 minus pressure due to the water vapor. What is the pressure due to the water vapor is given as 40 mm. 640 minus 40, 600 mm. 600 mm. So what is the mole ratio? 3:1. So partial pressure due to nitrogen, is equal to mole fraction due to nitrogen into total pressure. How to get the mole fraction of the nitrogen? Since mole ratio is 3:1, mole fraction of the nitrogen is 3/4, and what is the total pressure? 600. So pressure due to nitrogen is 450. Pressure due to the oxygen will be equal to XO2, mole fraction of the oxygen, multiplied by total pressure, 1/4 into 600, that is equal to 150. So partial pressure of the nitrogen in this sample is 450 mm. Option 3 is the answer. What is given initially? The pressure of the moist gas is given 640 mm. How to get the pressure of the dry gaseous mixture? Total pressure minus pressure due to the water vapor, 600 mm. What is the mole ratio of the nitrogen and oxygen? 3:1. Then what will be the mole fraction of the nitrogen? 3/4. What will be the mole fraction of the hydrogen? 1/4. The molecular weights of two ideal gases A and B are respectively 100 and 200. 1 gram of A occupies 3 liters of volume at STP. What is the volume occupied by 1 gram of B at STP? So what is the point here? The ratio between the, because at constant they have given when temperature and pressure are kept constant. When temperature and pressure are kept constant, volume is directly proportional to the number of the moles. Volume is directly proportional to the number of the moles. Volume is directly proportional to the number of the moles. VA by VB is equal to NA by NB. What is VA? Volume 1 gram of A occupies V liters. VB is not known. How do you get NA? Weight by molecular weight. What is the molecular weight of A? 100. What is the molecular weight of B? 200. So V is equal to VB is equal to 2. So VB is equal to V by 2. Option 1 is the answer. Two samples of gases A and B are at the same temperatures. The molecules of A are traveling 4 times faster than the molecules of B. What is the ratio of their molecular weight, Ma and Mb, of their masses? Temperature is kept constant and mass is velocities. A is traveling 4 times faster than molecules of B. The ratio of the masses, PV is equal to 1/3 mnc square. PV is equal to 1/3 mnc square. Because what is the simple point? Velocity is inversely proportional to the mass. Or rate of diffusion is inversely proportional to the molecular weight. RA by RB is equal to root of MB by MA. This is nothing but rate of diffusion. Rate of diffusion is inversely proportional to the molecular weight. Now molecules of A are traveling 4 times. This value is 4. MB by MA MB by MA. So what will squaring 16 is equal to MB by MA, and MA by MB will be equal to MA by MB is equal to 1 by 16. 1 by 16. This is option 4 is the answer. Next, a gas, 16th question. A gaseous mixture, this is nothing but application. The previous question is application of Gram's law of diffusion. A gaseous mixture of three gases A and B, C. The total pressure of a mixture of 6.4 grams of oxygen, 5.6 grams of nitrogen present in a 2-liter vessel is 1200 mm. What is the pressure, partial pressure of the nitrogen in mm? So to get the, how to get the partial pressure, how to get the partial pressure, mole fraction into total pressure. What first find the ratio of the number of the moles. Number of moles of oxygen is to number of moles of the nitrogen. 6.4 by 32. 6.4 by 32 is to 5.6 grams. 5.6 by 28. 5.6 by 28. So the ratio of the molecular weights is 1:1. Ratio of mole ratio will be equal to 1:1. 1 by 5 and 1 by 5, 1 by 5, 1:1. Therefore, mole fractions of oxygen is equal to 1 by 2. Mole fraction of the nitrogen is equal to 1 by 2. Partial pressure of the nitrogen is equal to 1 by 2 into 1200. Total pressure, that is equal to 600 mm. Next. X grams of the water is mixed with 69 grams of ethanol. The mole fraction of ethanol in the resulting solution is 0.6. And what is the value of X in grams? So here the ratio of mole fractions, x1 by x2 will be equal to n1 by n2. x1 by x2 is equal to n1 by n2. Mole fraction of the alcohol by what is other? Mole fraction of the water is equal to number of moles of the alcohol by number of moles of the water. Ratio of mole fractions will be equal to ratio of the number of the moles. Now what is the mole fraction of the ethyl alcohol? 0.6. Then obviously what will be the mole fraction of the water? 0.4. How do you get the number of moles of the ethanol? Weight by molecular weight, 69 by 46. X by 18. This value is 3 by 2. So 3 by 2 by x by 18. So x will be equal to 18 grams. Next question. A cubical vessel has a side with 1 centimeter length contained in a gas at a pressure of P. When the side of the vessel is made 1 by 2 centimeters, the pressure of the gas becomes. So in a cubic vessel, pressure will be equal to when the side of the vessel is made by L by 2 centimeters. So pressure is inversely proportional to the volume. When the length of the side is reduced to L by 2, the pressure will be increased by a factor of 8 times. Pressure will become 8P. In a mixture of N2 and CO2 gases, the partial pressure of CO2 is 1.25 atmospheres. The total pressure of the mixture is 5 atmospheres. What is the mole fraction of the N2? So total pressure is 5 atmospheres. Total pressure is 5 atmospheres. Total pressure is 5 atmospheres. 5 atmospheres. Total pressure is 5 atmospheres. Partial pressure due to CO2 is 1.25 atmospheres. 1.25 atmospheres. Partial pressure of the nitrogen will be 3.75 atmospheres. So partial pressure of the nitrogen is equal to mole fraction of the nitrogen into total pressure. Mole fraction of the nitrogen will be equal to partial pressure of the nitrogen by total pressure. 3.75 by 5 atmospheres. 3.75 by 5 atmospheres, which is equal to 0.75. Option. We'll continue in the next class.